Hello everyone, today we're going to look at USACO training number triangles. In this problem we're given a triangle with r rows and then each node has a specific value, and then let's define a route as like a way from basically a route from the top node to one of these bottom nodes. So an example would be from 7 to 8 to 1 to 4 and then to 2. And then the value of this route would be the sum of some of the values along this route, which would be, in this case, 7 plus 8 plus 1 plus 4 plus 2. And then we're supposed to find the maximum value of a route of all the possible routes. An example, or the answer to this question would be, or to this triangle would be, to start from 7, you would go to 3, you go to 8, you go to 7, and then you go to 5. And this would be the highest sum, and this would be 30, since this would be equal to 7 plus 3 plus 8 plus 7 plus 5. Okay, so we're just given the triangle, and we're just supposed to output the longest or the largest sum. Okay, so let's first let's take these samples. We have 1, 2. This is just our rows, and here's our columns. Okay, so our values we have 7, 3, 8, 8, 1, 0, 2, 7, 4, 4, and whoops. Okay, 4, 5, 2, 6, 5. Okay, so let this be denoted as value of, let's call this I, and here's our j, so this would be value of ij. Okay, so then we could also have another array. Now explain later. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, so let's call this thing dp. So dp of, let's just say, row I and then column j would be the maximum route, basically from 1, 1, or the top node, from 1, 1 to ij. So for this example, we know that the top node is always the same thing as the value, so we know that this is 7. And then for 1, 2, you can see that the answer for this would be 7 plus 3, which would be 10. And then since this value we see as 8, let's mark this as done. You know that the value of this would be 7 plus 8, which would be 15. Okay. So then let's look at this. So we know that for this value, because basically you can draw it like this. You can have 7, 2, 3, 8, 8, 1, 0. Okay, I'm just going to draw 3 rows, but notice that 3 points to 8 and 1, which you can see that it is basically directly beneath and then to the right. And here again you see that 8 points to 1 as well, then 8 also points to 0. So basically over here you can like draw this kind of like comparison, basically just like linking these nodes. Okay, again. Okay, let's draw this, that, this, that, this, that, and this, and that. Okay, so now that you know that, you can see that dp of ij is basically equal. For example, if you have 1, it'll be equal to dp of 3 and 8 plus your current value. So I'll explain. So over here, as you can see, since 8 only has one parent, which is 3, it would be equal to 10 plus 8, which would be equal to 18. For 3, 2, you can see that 1 has 2 parents, which is 3, which is 3 and 8. So then you would take the maximum of that since you want the maximum route. So then it would be equal to the maximum, these two nodes, which is 10 and 15. And then 15 would be the greater node. So then it would be equal to 15 plus 1, which would be 16. For 0, you only have one parent, so this would be equal to 15 as well. Okay. For the fourth row, you can see that 2 only has one parent, so then it would be equal to 18 plus 2, which is 20. Okay, for 7, you can see that it has two parents, 8 and 1. So then you would take the maximum of 18 and 16 plus 7, so then this would be 25. Okay, for 3, which is this node, you can see that it has two parents, one, like these two nodes, so then you would take the maximum of these two, which would be 16 and 15. It would be equal to 16, then you would add 4, this would be 20. Okay, this only has one parent, so this would be 19. Okay, and then 4 also only has one parent, so then this would be 24. Okay, for 5, you see that it has two parents, 2 and 7, so then you would take the maximum of 20 and 25, and then you would get 30, since 30 is equal to 5 plus 25. Over here, you have 2, which has two parents, then you would take the maximum of 25 and 20 plus 2, this would be 27. Okay, for 5, 5, for 5, 4, you have 6, which has two parents. And then the answer for this would be equal to the maximum of these, which would be 20, plus 6, which would be 26. Over here, for our last node, 5, you only have one parent, so then it would be equal to 19 plus 5, which would be 24. So then our answer would just be the maximum of all these nodes, which would be 30, which is what we want. Okay, so that's basically it. And then let's get to code. Okay, bits. Okay. Okay, so we have our R, which is the number of rows, and we have our vowel, and then let's have our maximum n. Okay, so we have vowel of max n. Since it would be 2D, we would have max n as well. Over here, we need to read from numtree.in, and then you need to write to numtree.out, because you need to read R. Okay, so basically we can label this from 1 to R, not n. And then our j would be equal to 1, and then be less than or equal to I. So then you would just read val of I, j. Okay. So now, remember we need our dp value, so it's also max n. Okay, so you know that dp of 1, 1 is always val 1, 1, since there's only one way to go from 1, 1 to 1, 1. Okay, so now we need to calculate our rows from I equals 2 to I equals R. Okay, again, you will also do and j equals 1. Okay. So now you can see that basically, because we have a few cases. If it is the first node, it only has one parent. So if j equals to 1, it would have one parent. And if j equals to I, it would also have one parent. So we can handle these cases separately. So if j equals to 1, then your dp of ij would be equal to your dp of I minus 1, j plus val ij. Or we can actually simplify this by setting this, so dp of ij would be equal to val of ij. Okay, so now you would just add this. Okay, so for our other case, it would be else if j equals to I. So then this would also only have one parent, which would be I minus 1, j minus 1. dp of I minus 1, j minus 1. Okay, so now, if it's not this, our dp of ij would be the maximum of our dp of I minus 1, j, and dp of I minus 1, j minus 1. Okay. So at the end, let's have our answer. We call it, originally it should be 0. So then, for each of your like last row, your answer should be the max of your answer. Since you want the maximum of the last row, dp of r and then I. So then, you just need to write your answer. Okay, so let's run this run main. Okay, wait, actually we didn't, let me just fetch the input. Okay, so there we go. Okay, it's running. Okay, yeah, numtree.in. Just going to, whoops, sorry. Okay, just finished running 24, which is not what we want. Okay, so let's spend some time debugging. Okay, so this should actually be plus equal, since we already set the value and we actually want to add the value as well. So let's just run this again. So run main. Okay, so let's actually put my ID here. Whoops. Okay, ID $3. Whoops. This problem is num3, and then the language is C++11. Okay, so let's check if it's right. So 30 is right. Let me go submit this. So here we go. I'm gonna select the file. Okay, so this is number triangles. Let's go. And looks like that is right. Okay, so if you have any questions, feel free to leave them in the comment section below. Bye.